Good afternoon and happy spring. My name is Rob Romanowski, and I'm the Director of Sales Operations with 3HTI. And today we're going to take a closer look at the Advanced Assembly Extension for PTC's Creo. So leading the webinar is Paul Dye, who is a Solutions Consultant and Applications Engineer with PTC's Virtual Center of Excellence. Paul always does a great job. Come to know Paul pretty well over the past several years working with him, and looking forward to seeing this webinar today. So if you have any questions, type them in the Q&A box and we'll answer them as we go, but we'll definitely get to your questions, all of them at the end. So without further ado, Paul, you have the con. Lead us, my friend.
All right. Thank you, Rob, for having me on. And you could see my screen, hear me okay?
Yes.
Awesome. So yeah, thanks for having me on. Like Rob mentioned, I'm a solutions consultant, application engineer, pre-sales technical specialist. I've had a lot of different names or titles. At the end of the day, really just working with our software at PTC, primarily Creo. And so I've worked with a lot of different people, talked to a lot of different companies around their design process, their design workflows. And there's a ton of different extensions in Creo that we work with. But I'd say at the end of the day, one of the most important ones that we really see a large majority of our customer base getting use out of is advanced assembly. It's something that I'm going to go through a little bit more and talk to. But if you're getting more complex designs, if you're starting to get your part count up and starting to really need to have a way of managing that process of working between those teams, you need a tool to help you out there. So that's what I'm going to go over today. There's going to be some different topics that I'm going to cover and show in the context of Creo. I'm going to start with, first and foremost, some of the different challenges that we see as part of this process. I'll go through advanced assembly, some of the capabilities, walk you through a couple of different workflows, and we'll talk a little bit about really some of the benefits that a lot of our customers are getting out of using it. So first of all, looking at some of the different challenges, and these are challenges that pretty much every single design process that you come across is going to have to work with, right? Especially whenever you're working with larger assemblies, there's going to be multiple different people, designers, or even different teams working on it. And you need to be able to work together. You need to be able to share information appropriately, effectively, keep everybody on the same page, and you need to have some way of controlling that process. You don't have two people working on the same thing and they don't know about it or moving in opposite directions. It's something that we see a lot of times. And as assemblies get larger and more complex, you can see those types of errors happening more and more, right? And the losses in productivity become larger with that as well. So big issues there. There's also some teams that you might work with that aren't even inside of the company. They might be different partners or suppliers where you need to be able to get their information. You need to be able to share off your information with them, make sure that your information is matching. But at the same time, you might not want to share all of that intellectual property with those outside companies. So you need to be able to secure it, but at the same time transfer the information that you need to. And looking at CAD tools in general, they tend to be pretty limited whenever you're working with these types of designs, especially whenever you have 10, 15, 20 other people working on something. You need dedicated tools to assist you there. And if you don't have a system in place to work with these larger, more complex assemblies, it could be very slow or tedious process to plan, to document, to go through and assemble these different types of designs. So whenever it comes to working or sharing or collaborating, what can we really do? Right. So we've thought about all these different things, and we thought about them a long time ago and really built out solutions from within Creo to help you out with it. And that's what we use right here from within Advanced Assembly. It's really giving you design tools specifically built out to combat the challenges that you typically see with large and complex assemblies. It's looking to speed up that assembly process among your design team, with outside teams, even all the way down to manufacturing, and then still be able to effectively, at the end of the day, manage everything throughout that process. And a big concept here with what we do in advanced assembly methodology really is top-down design, where we want to be able to plan out the framework for how this assembly is going to go together, what it's going to look like, and have that all planned out from the beginning. And that's really working with the idea, first and foremost, of skeleton models. You'll see this whenever I go through the demonstration, but we're essentially laying out the framework for which areas of the assembly that we're working on, gives us the ability to share and work with only the areas that we're concerned with. We also have a reference viewer in this tool as well for viewing and managing all the different references and dependencies between the different parts, assemblies, sub-assemblies. And you definitely want to have full control over that in the model. So defining the scope for the model, where each part's connecting together. We really want to manage those references from the beginning and understand those. So as the models get built out over the course of time, they're more flexible. A lot of times you see people that go through and don't work from a top-down perspective. You get to the end of a design process, and if you want to make changes, your model's just not very flexible anymore. It isn't able to be moved or configured. That's what we want to do here, is make sure that by the time you get to the end of a design process, you still have the ability to go through and make modifications to any of that input that you started with. And along with this is also the process of concurrent design, which is a similar concept, but the idea now is that we're going to be working together. So you could see in this image here, you have a lead integrator or designer that has almost like the framework for, in this case, it's a knife design. And they're going to share off using different geometry sharing techniques that we have in advanced assembly, certain pieces of this. On the left, you see a skeleton model, right? That's going to be these different arcs or lines or surfaces, whatever it may be. And they'll share off those different pieces of that skeleton to each designer or engineer. One might be in charge of the handle, one for the blade, one for the switch mechanism, even some people that might be working with partners and suppliers that are pulling in some non-native CAD data. And the idea is that everyone now is working off of that same framework. And then later on, if you have, say, a design review, you're able to go through and make changes, right? So if, say, the lead integrator makes a change to that initial sketch that you worked with, and you say, yeah, maybe I don't want it to be as curved there. Maybe I want to have 3 grooves for the fingers instead of 2. Well, they just go through and update that. And because everyone was working off of that lead integrator, all those different designs are going to be fed down and be able to still work with one another. And you're, again, able to be more flexible with that as well. Another thing that we use here a lot of times is also inheritance models. This is controlling whenever you make changes to a certain part or some assembly, you can create inheritance models that those get cascaded down to. The idea is maybe you have certain parts for this blade that's going to be your design model, but then maybe you have another one that's going to be your finite element analysis model where you do some defeaturing, or there might be one for manufacturing where you're taking into account, say, shrinkage, for example. You can make those modifications and then have a lead inheritance model, almost like the parent model that this changes all get cascaded down to, but the changes on each individual level don't get made. So a very powerful tool that we see a lot of our customers working with there. We also have the idea of assembly configuration. We have tools such as interchange groups for things like fastener attachments, where they're always going to go on the same way. You shouldn't have to spend a lot of time setting that individually. So maybe if it's something like a custom electronic fitting where we're just trying to make it mount, all we have to do is pick a face where it's going to go, give it a location, and it's going to be able to be changed up depending on what your order might be or what type of configuration that you're working with here. The idea here that we can really support is something like design to order, where you're starting with a standard configuration, but then you have 5 pieces of your design that can be swapped out with others depending on a certain customer's orders, for example. So there might be one configuration you never build out, there might be one that you build out a ton, but the idea is you're ready in an instant to go ahead and get that new configuration for your model based on what you need. We also have the idea of defining the process planning, so understanding how the model needs to go together. Well, you need things like graphics, bills of materials, all that for manufacturing to show how this is going to go together. And we're able to define it here using that engineering information. So that's something that advanced assembly also allows us to do, is a bit of this process planning and building out some of that documentation. And this really plays in well with all the tools that we have for visualization and performance management. If you have a big assembly, that's a huge amount of data that your computer has to crunch. So we want to really give you the tools to control that. If you only want to look at a particular area, you can turn other areas of the model off, or maybe show certain parts as only a shrink wrap or a more simplified representation of the model. So it's reducing the time it takes up to load, put it to memory, and work with it. So these are all capabilities that we're really getting as part of the advanced assembly extension, and all things that we're going to go through and work with here. I'm going to go through and show a demonstration of some of these different techniques that we use throughout advanced assembly, so you can get at least a glimpse into the process of what the workflow would look like. Obviously, there's going to be a lot more that goes into it and more that you can do with it as well, but I really just want to expose you to what that workflow would look like here from within Creo. So if you have any questions, feel free to drop those in and we can go ahead and answer those. And you get to put those in at any point while we're going through here. Right. And so for our demonstration, we're going to be working on a train. And Obviously, anything remotely approaching the size of a train model is going to be pretty big. There's lots of pieces, lots of work from start to finish. Even if you just break it down to a particular car or locomotive, it's a lot of geometry. And advanced assembly is really all about managing the model, keeping track of when you're working amongst your teams, who's controlling particular geometry, who's working on certain areas. It's really what advanced assembly or AAX is all about. First of all, like I mentioned, it revolves around the idea of a skeleton model. Skeleton model can be different lines, arcs, curved surfaces, anything that you want to use to set the overall control for that model. And the idea is once you have the skeleton model, I can say, okay, take these certain surfaces, take these curves, and I'm going to publish them and use them for particular purposes, maybe for structural components, maybe from that same skeleton model, we want to make another set of published geometry for our internal surfaces. So maybe we'll grab a surface over here. Let's go ahead and get one for the window here, some of our different internal components that we have there. And we're going to publish this out, and these are going to be for our interior components. And so what we want to do with that now is once we publish those out, we want to feed those down to the different areas that people are going to be working on. So here we can go into these other sub-assemblies and go ahead and pull only the geometry that we really need, which was published out for us to have as a reference to go through and do our design work. This could be me pulling this into my own particular sub-assembly to help with the data that we're crunching. It could also be something that we share out with different designers on the team. Maybe we have someone that's working on this interior assembly here, and we just want to share out that published geometry that we had from the lead integrator. They can just go ahead and take that in, and now they have what they need to go ahead and do their work, all from that published geometry and all defined from the skeleton model at the top level. All right, so now we have our skeleton set up and published out. We can go ahead into my structural model here. And inside of here, I have that skeleton model and might have some of the geometry that I built out here. But I'm going to grab that published geometry that I had earlier and work with it inside of here. And from here, we can really just do some normal CAD Creo work. I'm going to build out some additional support hoops to help the structure. I can just simply use the curve, in this case, to do a sweep of the shape to show you how it would work. Go ahead and sweep that section along the curve. And now I have my beam profile. And then from there, again, just some standard Creo work. Go ahead and cut out where the upper support structure goes, shell it out to a different shape. Whatever you're going to do, just normal design work as you would do on a day-to-day basis. The idea is the master overall shape is being controlled by that top level skeleton geometry. And that's really what the advanced assembly is all about. It's making it very easy to make those connections, to control them, and as you can see here now, changing them. So we can go ahead and pattern the hoop along the length of the cart. And now my support structure is looking good. I got my new hoops, all that geometry, so I can go back and turn on the rest of my structural assembly. And you'll see throughout this, I'm using some different lightweight representations. If I don't need to see all the part or just certain parts in particular, you can turn them off or on or to lower level representation throughout that as well. And we can move on here to our interior. And maybe I need to build out something like a wall, work with just a piece of this. In this case, I have the existing wall, and I'm going to go ahead and punch out where the window goes. Well, I need to know what's the size, what's the shape of the window. Well, that's what we can use from the published geometry that we got from the skeleton. We can go ahead and grab that loop here. We're going to make a form feature out of it. We'll assume that this is a sheet metal piece and it's going to be punched out. Give it some thickness here. In this case, I'm giving it a little bit of extra because I know I'm going to trim it down based on the surface that we have from the master model. Just give it a taper there and round off some of the edges. And there we go. And as you can see, it comes out a little bit further than we need. So we'll go ahead and cut it down using a curve that we pulled in from that skeleton geometry. So that's something that we used using the geometry sharing techniques, still letting the master model control all of it, but just using it here inside of my work. And I don't have to have the whole train if I'm just working on the interior, don't have to load up all that other geometry. And now it's looking pretty good. We have windows, so our passengers can actually see outside of the train. It's definitely a good step in the right direction. So we'll go ahead and turn the other walls back on, generate the model, and we're good to move on. I think the interior is looking pretty good there. And we'll go back to the top level. And if you're working on the top level, maybe you'll set some of the lower levels to a more simple graphical representation without all that data being loaded up. And we can go ahead and keep working on here to some of these other areas like the doors. And it'll be the same sort of thing. I have my skeleton model inside of my door assembly. In this case, I also have a shrink wrap of the rest of the geometry. I need to work on my door, but I want to be able to see the rest of the piece, but I don't necessarily need to work with the entire car assembly. Well, I can bring down things like the shrink wrap of the existing floor structure and go ahead and work around it. All right, from here, I'm going to go ahead and take that published geometry that we had from before. But in this case, as you can see, I want to be able to control this. So you can see in this update control, you can decide whenever something happens to that top level skeleton geometry that was published out. In our case, we have it set to just automatically update. So if something were to change, we'd be able to be very reactive to that and it'd be able to be updated based upon those changes. But you can also set this to be a manual update with a notification if you'd like to. That's really going to show that you have different options here. If you don't want things to be automatically updated without your knowledge, you can go ahead and say, hey, just give me a notification so I can go ahead and see that. So we'll see what that looks like in a little bit here. But from here, we can just go ahead and keep going through and making some changes. We'll use the surface feature. That's going to be that surface quilt that we copied from the skeleton, and we'll make our door out of it. Let's give it some thickness. Let's go ahead and cut some windows out here, see how that looks. There's probably going to be another big drawn sheet metal part. We'll go ahead and shell that out and give it a thickness here. Let's give that a value. And we're good to go. So now I have the base structure there for the interior of the door, and we can go back here and turn on the rest of this so you can kind of see where we're going with all of this. That's looking pretty good here. Now I have my door structure. Again, door defined using the master skeleton model that's controlling all of that. And let's go back to our master representation to see all the geometry. Load that up here. And that's really, again, with the advanced assembly extension, what you're doing is setting these different representations, copy geometry to the particular areas that you work from it, and still set up the skeletons to keep control of everything. And that's really what you need to do in order to work with models that are of this complexity. Otherwise, you have too much in front of you. So from this point, now that I have this all set up, and I want to go ahead and make some changes, right? This might be later on where we need to make some changes to some input geometry. One thing that you could see here that we're able to work with, and this is something that anyone that's working on subscription base of Creo, pretty much any of our modern base of users now has access to, is design exploration. And this is a very powerful tool, but at the same time, very easy to use. And what it's really doing is just saying, hey, I'm going to keep track of the things that you're doing and allow you to set up checkpoints at any time that you want to make a change. And it's going to give you reference back to that. And you could branch off into different areas. You can go through and do some exploring. If you like it, keep it. If you don't, just go back to a previous one. Really allows you to do some of this design exploration in a very safe environment that doesn't risk you making any changes to the model that you wouldn't want to have changed. Right, and we can go ahead and do just that here. So this is what we built everything from. Maybe during a design review, we realized that we need to go through and thin down the bottom of this to meet a compliance, whatever it may be. Let's go ahead and bring over that profile and change the skeleton, and we'll let things update here. And really what happens is everything updates. Because it was all defined from that skeleton model, that's exactly what I want. So it's made sure that everything's been changed there. And there's actually one thing that didn't change, and that's because earlier we specifically said that we want this one to be associative, but I only want it to update manually. I want to be able to see what actually changed here. So what I could do here is some examining of the model. It allows us to see exactly what happened with that change. So here we can see exactly what it looked like before the outdated version of it. You can see there in orange, we have the new changed version of the model. So we can go ahead and take a look there. And if we like what happened, if we like the change, we can go ahead and allow that to update. And here you can see with design exploration, after I make a change, we can just go ahead and drop a checkpoint in there. That'll be almost like a way marker that we can reference back to at any point along this design exploration that we're trying out here. Right, and let's go ahead and keep moving on here. Right, let's open up a cross section so we can see right inside of this train card assembly. And now I want to make a change. And this really becomes normal Creo work. Maybe I want to make a change to the armrest, wherever it might be. What the design exploration is basically doing is it's watching the changes that we're making, and it's allowing me to say what I like, what I don't like, branch off into different areas that I'm interested in exploring. In this case here, it's changing the armrest. We can go through and see what they look like there. And you can actually get some pretty granular detail into this as well and see exactly what was changed, what was created, if something was renamed or suppressed. Get some low-level information there as well. And like before, if you want to make a checkpoint at that point, you want to be able to reference back to that particular spot in your design process, go ahead and drop it in there. So really have these different tools to help you out for this, especially if you're doing more complex work and it's doing changes that might affect multiple parts of the assembly. You can have control over that and say whether or not you want to keep it or not. If you do, you want to keep it, just put a checkpoint right there, and you can go ahead and accept that. And only at that point then is it going to be saved to the real model that you are working with there. So really a completely risk-free environment for going through and making changes to the model. But at the end of the day, we have a new shape, we have a new profile for the cart. All of it's being controlled through advanced assembly, really giving me the ability to work on these large assemblies much more quickly and have a lot more control. Yeah. So again, if you have any questions on anything that I shared here, feel free to drop that in. And I'll just wrap up here by kind of leave you just thinking about some of the real benefits that a lot of our customer base and a lot of our users are really getting a lot of good use out of. So first and foremost, we're going to be able to reduce time to market. If you and your team can all work together in a more streamlined product development system, you're going to be able to get products out to market much faster. And at the end of the day, the products that you're designing, they're going to be improved quality. You don't have things getting out to the shop floor, and then you go through and put it together just to realize that it's not going to work. And same thing with supplier products that clearly, if you would have been able to share enough information, you could have made it work. So improving that product quality and really start innovating and putting this together, you're developing and defining into new markets because you're able to try new things. Like you saw with the design exploration, you can try many more variations of your assemblies that you've created. And at the end of the day, using advanced assembly to control that process and eliminate a lot of those errors overall. Okay, that covers everything that I wanted to touch on today. Definitely some awesome capabilities. And if it's something that you have interested in, we're more than happy to have conversations around it. And with that, I can pass it back over to you, Rob.
Paul, great job as always. Thank you very much. So that's going to conclude our webinar for today. If you have any, if you want to see a more detailed demo specifically to what you're modeling and what you're doing with Creo, anything Creo, including the Advanced Assembly Extension, you can reach out to us at info at 3hti.com, or you can just respond to the emails that are sent to you inviting you to these webinars. So not sure if everybody, if this is appropriate for everybody, but next week we're having a webinar on Windchill. It's an introduction to Windchill PLM. So I will be sending that link to that webinar in the same email with the recording to this webinar that should go out sometime tomorrow. Paul, thanks again for all your help, and we thank our audience for being on. Have a great day and enjoy the spring. Take care.